Go. You're welcome back. Week 4, day 1. Remember to leave an empty space at the top for the topic's name, and then on the right corner, September 13th, 2021, the date. Okay, so today we're going to define some things before we get into the topic itself, before we get into equations, because that's what we're going to see next, equations, okay? So you have several words in there. What do you think when you hear the word term? What comes up to your mind when you hear the word term?
Meaning?
Yes.
Meaning? Term?
Yeah, what does term means for you?
Another way to call.
Another way to call? To call what?
Mathematical phrases?
Okay, yeah, very good. That's an answer. That's a correct answer. But we're going to do it in a simpler way. So a term is a number, a variable, or the product of them. Okay, that's a term. I'm going to give you some examples. Okay, so for example, do it in blue. 3 is a term. X is a term. 4y is a term. And terms can also have exponents. So for example, 5w to the square. All of those are terms, okay? From those terms, we can have a constant. What is a constant? Constant. As the word says, constant. It is something that does not change. A term, it does not change. Okay, and we're missing here another one. Another term, which is variable. What does variable mean? And I think we saw this already, this definition. So what does variable mean? Before giving any example of what a constant is. So if constant means a term that does not change, variable is a term that changes. So it represents an unknown value. That's why it can change, because you don't know how much it represents. It could represent 1, but it could represent -1. It can even represent 0, a half, 0.5. So it can represent so many things that we do not know. So we're going to say that it represents a variable, an unknown value. It can change. And it is usually a letter. Okay? It is usually a letter. What letter? Any letter that you can imagine. Okay? That's a variable. Any letter that you can imagine, except O. Letter 0. I mean letter O, because it is kind of like 0. So we're not using letter O. It's not that it cannot be, but it's just that we're not going to use it. Okay? So a constant, a term that does not change. Let's add something else in there. In other words, a number without variable. Okay? So a number without a variable, that's a constant. For example, 7, -4, a half, 0.24, etc. Okay? Those are constants. And variables, it could be any letter. It could be X, Y. Those are the ones that we use the most. Z, but it can also be A, H, etc. Okay, and that is a variable. Now we're going to define like terms. So if we know that a term is a number, variable, or the product of them, what are like terms? What are like terms? Emily, your camera. What is a like term? Anyone? So the hoodie. What is a like term, guys? What do you think? If you have here the definition of term. So what is a like term?
A number, variable, or product that are similar to the other equation.
Exactly, to the other term. Perfect, Elisa. Yeah. So yes, that's a like term, okay? Like terms are terms that are similar or are identical. But we're gonna say similar. It has to have the same variable and the same exponent. Okay, like terms are terms that are similar. It has to have the same variable and the same exponent. So for example, if I say 3y, this is a like term and placing a comma with negative 5y. Those two are like terms. They have exactly the same variable and each variable has an exponent 1, okay? So I don't need to have exactly the same number as long as I have the same variable with the same exponent. So for example, x to the square is a like term to 41 x to the square. It doesn't matter that this has no constant. It has an invisible 1, but this one has a 41. So it doesn't matter, okay, that they have different numbers or different signs as long as they have the same variable with exactly the same exponent. And that is a like term. We're going to move this a little bit higher. And now we're going to define coefficient. Since we know already the definition of term, of constant, of variable, and like term, now we're going to define what coefficient is. So a coefficient is the number that multiplies a variable. Any number that is right next to the variable, that is a coefficient. So I'm going to do different colors. For this one, for example, negative 5 is the coefficient of negative 5y. The one in green is the coefficient. The one in blue is the variable. Now let's find the coefficient for x squared. And I'm going to write this in red because it is an invisible one right next to x squared. Okay, so whenever you see just the variable and there's no number in front of it, that is an invisible one. Okay, so you need to know that every single time that you're seeing just a variable, the coefficient is 1. Now, if I say, for example, negative x to the square, we got a negative sign in front of the x squared. So what is the coefficient in that case? In that case, the coefficient is the negative sign that we got with an invisible 1. I'm going to place it also in blue. Okay, so the coefficient is negative 1. That's why it has both colors, because it is part of the term that they're giving you, but the coefficient is an invisible 1 that has a negative sign. Okay? Okay. And now the very last definition for today, simplifying variable expression. What is to simplify a variable expression? Okay, or how do you simplify a variable expression? Well, You simplify a variable expression by replacing it with an equivalent expression that has as few terms as possible, okay? So that's what we're going to say. We're going to say that it is simplifying a variable expression is replacing your original expression by an equivalent that has less terms as possible. Okay, so that is simplifying a variable expression. Now I'm going to give you an example of how we're going to do it. Okay, so if I have, for example, I'm going to start with something easy. I have 4G plus 3 parentheses 3G 3 plus G, okay? We have that. And we're going to use a lot of things that we have seen already. We're going to use properties. We're going to use PEMDAS, orders of operations, okay? In this case, we're not going to use exponents yet, okay? We're not seeing exponents yet, but then we're going to see everything else. So the first thing, according to PEMDAS, parentheses. Inside my parentheses, I have two terms. One that is a constant and the other one is just a variable. They're adding. I cannot add variables with constants. Never, because they're not like terms, okay? One doesn't have a variable, the other one does. So I cannot do anything in there. Oh, but I can totally multiply the 3 with everything inside the parentheses doing the distributive property. So let me see if I can move this a little bit down there. And I'm going to move this a little bit higher. So we're going to multiply the 3 times the 3, but also the 3 on the outside times the G. And the rest, I'm copying it, okay? So I'm copying 4G plus 3 times 3.
9.
9, exactly. And then 3 times G. What do we do when we're multiplying a constant with a variable? Remember, a variable is a term that we do not know the value. So what do I do when I'm multiplying a constant with a variable? Well, if the term has a number, you multiply the numbers. If it has a coefficient, you multiply the coefficients. But if it doesn't, then you go ahead and copy them both and multiply the signs. In this case, positive times positive, it's positive. Okay, I finished with the first part. I'm simplifying here, but I haven't finished, right? Why? Because I need to find the like terms. Okay, so let's find the like terms. So 4G, I'm placing that in red. 4G is a term that has a coefficient and a variable. Do I have another variable G? Remember that I don't care the number. 3G, positive 3G. We take into account the sign right in front of it, okay? Do we have a like term for 9? Is there another constant? No, so there's no need for me to underline it, okay? So I'm going to simplify. So 4G, I can rewrite it and write them one next to the other. It will get a time where you can skip this step, okay? You can skip this step, but not right now. Right now, I want to see everything. So I have 4G plus 3G plus 9. How much is 4G plus 3G? Then we just go ahead and add. How much?
7G.
7G. And since the 9 has no like term, I just go ahead and copy it. And this is the equivalent simplified expression for the original. And that's how we're going to be simplifying expressions. Do you guys have a question so far? No questions. Okay, then let's place a topic to this. What is the topic's name before we go to do any classwork or anything? What's the topic's name? It's in there. In the definitions, it's in there. What do you think the topic will be?
Simplifying variable expressions.
Exactly. simplifying variable expressions. And that is the topic for today. Now we're going to do a little quick exercises. That's how we're going to call them. These ones you are not going to upload them to Schoology. Not now. Right now, I just want you to have them in your notebook, okay? So, but there will be a moment where you will most definitely upload them, okay? So some quick exercises that you're going to be doing, and the instructions are simplify. Okay, that's your only instruction, to simplify. And what are you going to be simplifying? You're going to be simplifying several expressions. Okay, so exercise 1, it is x plus 3, so x plus 2 plus 3x plus 5 plus x plus 3 plus 2x. Okay, let's leave some spaces in here. That's exercise 1. Exercise 2.
Miss, you can move the mouse. I can see the first number. Oh, thanks.
You're welcome. Okay, those are the 5 exercises that you're going to be solving in your notebook. You're going to call them quick exercises. Your instruction, it is just to simplify, and then you simplify finding the like terms, just like the last exercise that I explained to you. Do you guys have any question about the topic?
No, Miss.
Okay, then guys, this is it for today and for today's class.